All right, let's go ahead take a look at the 2017 free response AP statistics exam. This will probably be a couple videos. The free response section is 50% of the overall score. The first 5 free response questions are going to make up 75% of that. And then after that, the last one, problem 6, is going to be 25%. So that sixth one is an investigation problem that's weighted just a little bit more. So I'm going to read through this kind of quickly. So if you need to take some time to read it more in depth, go ahead, pause it. But researchers studying a pack of gray wolves in North America collected data on their length in meters and weight in kilograms of the wolves. A scatter plot of weight versus length revealed a relationship between the two variables described as positive, linear, and strong. For the situation above, explain what is meant by those words. Positive, hopefully you said something like as length increases, so does weight. I saw some student responses also include an example, something like what it might look like. It's positive. As one increases, so does the other. I wouldn't just show an example, but if you want to use the example to add some strength to your written work, that's fine. Linear, something along the lines of the scatter plot more or less resembles a line. Also, it's something like you see up here, more or less the pattern makes a line. In strong, you should say something along the lines of the scatter is modeled well with a line. Something like the residuals are small. So I saw somebody also include, which is a counterexample, that when you see, this might be some type of linear pattern, but there's a lot of spread around the line. So this would be a counterexample to a strong linear positive association. The data collected from the wolves were used to create the least squares regression line. Predicted y is equal to negative 16.46 plus 35.02 times x, which again, that's length in meters, and this is weight in kilograms. Interpret the meaning of the slope. So say something along the lines of, for each increase in x, which is in meters, or length in meters, I'll even add, we expect, I'll also really underline expect because this is a predicted y, this is a least squares regression line. Use the word expect or we think, or it'll go up approximately, but we expect an increase of about 35. It's not in pounds, it's in kilograms. C. One wolf in the pack with a length of 1.4 meters has a residual of negative 9.67 kilograms. What was the actual weight of the wolf? So if there's a least squares regression line and we know that there's a negative residual of negative 9.67. Sorry, I shouldn't write that there. The actual residual is negative 9.67. So that actual weight is going to be under what the predicted weight was. So start by finding the predicted weight. predicted weight is negative 16.46 plus 35.02 times the actual length, 1.4. I'm going to assume you put that in a calculator and get your predicted to be 32.57. Then that would be this value right here, 32.57. Take away your 9.67, and the actual weight to be 22.90 kilograms. Remember, the something to know, the first question on the free response is usually going to be describing a situation. So this one was describing a linear pattern, a least squares regression. It could also be describing a histogram, a dot plot, or something of one variable, but still totally doable. Number 2, the manager at a local fast food restaurant is concerned about customers who ask for a water cup when placing an order, but fill the cup with a soft drink from the beverage fountain instead of filling the cup with water. The manager selected a random sample of 80 customers who asked for a water cup when placing an order and found that 23 of those 80 filled the cup with a soft drink from the beverage fountain. Thievery. Construct and interpret a 95% confidence interval. So remember, confidence interval for proportions is a p hat plus or minus the critical value z star times your standard error p hat q hat over n. So it gives, well, first of all, we need to do some conditions and assumptions. Does it state random? The manager selected, so the sample is random. And independent. Let's figure out our p hat really quick. Our p hat is 23 out of 80. That's an 80, not an 86. Off the top of my head, that should be right around 29%. So 29% of 80 is 23. So that means 71% of 80 is going to be 57-ish. So 10 success, 10 failures, and 80 is less than 10% of all, assuming all people who order at this restaurant. Okay, proceed with one proportion z interval, and we'll be happy about it. So we have our p hat is 29 plus or minus z star for 95% is 1.96. That should just be ingrained in your memory by this point. Otherwise, use some inverse normal. 71 over 80. Go ahead, pause. You can put that in the calculator yourself. But I got on the low end 18.8% and on the high end 38.7%. That'd be a lot of people cheating on their water. It asks us to interpret, so I'll say we are 95%. That is the air conditioning in the room I'm in. We're 95% confident that the true proportion of people who fill the water cup with pop is between 18.8% and 38.7%. I'll put B on the next video.